So, Jain student, here we are with a new topic, that is determining the nature of the decimal expansion of rational number. What do you mean by nature of decimal expansion of a rational number? We will explain this topic with the help of few examples and explanation. See here, suppose we have a rational number in form of p upon q, where p and q are co-prime. Co-prime means there is no common factor between p and q. If there is any common factor, so first remove that common factor and make it in simplest form. So if q is in form of 2 to the power m 5 to the power n, it means that if we have a rational number in form of p upon q, so we can write it as p upon 2 to the power m into 5 to the power n, where m and n are non-negative integer. Non-negative integer means either m n can be 0 or positive integers, right? So p upon q is a terminating decimal expansion. Terminating decimal expansion. What is the necessary condition for terminating decimal expansion? Any rational number which can be represented in form of p upon 2 to the power m into 5 to the power n. And one thing you have to always notice, that there is no common factor between p and q. If there is any common factor, first remove that common factor. By prime factorization, we can remove the common factors. So a rational number which is represented in form of p upon 2 to the power m into 5 to the power n are said to be terminating decimal expansion. Now if the given rational number is terminating, right, so it will terminate after some digit, right? So after how many digit it will get terminate? So you have to see that a given rational number has written in form of p upon 2 to the power m into 5 to the power n. See which power is greater, either m will greater or n will greater, right? If m is greater, so the decimal expansion will terminate after m digit, and if n is greater than m, so the decimal expansion will terminate after n digit. Now see here, if the rational number p upon q cannot be written in form of p upon 2 to the power m 5 to the power n, so p upon q is non-terminating and it will be repeating decimal expansion. We all know that rational number is either terminating or non-terminating repeating. So for the case of terminating, the rational number can be written in form of p upon 2 to the power m into 5 to the power n, and for non-terminating, rational number cannot be equal to p upon 2 to the power m into 5 to the power n, right? Now we will introduce this topic with the help of example. See one example. You can see here 64 upon 910. For checking that the given rational number is terminating or non-terminating, right? If non-terminating, there will be no decimal expansion, and if terminating, there will be some decimal expansion. See, in terminating and non-terminating, in both cases there will be decimal expansion, but in terminating we can terminate the decimal expansion after some digit, but in non-terminating the decimal expansion will in continuation. Now see, first we will factorize 64. It will be 2 into 2 into 2 into 2 into 2 into 2, 6 times 2. When factorize 910, it will be 2 into 5 into 7 into 13. 2 will be removed because this is the common factor. I already told you that p, in case of p upon q, there will be no common factor. You can see here 2 is common factor, so this will be removed. Now 2 into 5 times will become 32, become 5 into 7 into 30. You can see here that in denominator there is 5 into 7 into 13. This is not equal to in form of 2 to the power m into 5 to the power n. There must be either 2 or 5 or 2 to the power any number into 5 to the power any number. See, in numerator whatever is there doesn't matter, but in denominator either 2 or p upon either 5 to the power something whatever, right? और या तो ये हो या तो ये हो या तो फिर 2 to the power m into 5 to the power n हो, इसके अलावा कुछ और अगर नंबर आ जाता है, it will not be a terminating decimal expansion. So it will be 64/10 is non-terminating repeating decimal. If non-terminating, so it will be repeating, right? Now take one more example, 15/1600. So when we factorize 15 will become 3 into 5, and when we factorize 1600 we'll get all these expansions. Now see that 5 is common in both, so remove 5 in numerator from denominator. It will become 3/2 to the power 6 into 5. You can see here that in denominator there is 2 to the power m into 5 to the power n. There is nothing, so it will be 1. So 3/2 to the power 6 into 5 to the power n. There is no extra number, right? So it is in form of p/2 to the power m into 5 to the power n. So this will be terminating decimal expansion. Now see, if 3/2 to the power 6 into 5 to the 5 is terminating, so after some digit it will get terminate. What do you mean by terminating? It means that 0.625 it is terminating, right? There is nothing further, right? So it is terminating decimal, and after how many digit it get terminated? 1 2 3 digit. After 3 digit it get terminated. In this case this will happen. Now see that 3/2 to the power 6 into 5 to the power 1. M is 6, n is 1. Which is greater? M is greater. So after 6 digit the decimal expansion will terminate. It will terminate after 6 digit. Now further one more question arise, that after how many digit? 6 digit it get terminated. One more question is, write the decimal expansion of the same. Decimal expansion, for writing the decimal expansion you can see that 3 into, you can see that the rational number was 3/2 to the power 6 into 5 to the power 1. Make the power same. For making the power same you will have to multiply with 5 to the power 5 in numerator and denominator. Why? Because when base is same, power will be added, it will become 5/166, right? So powers are same, 6, right? So 5 to the power 5 into 3 will become 3/125 in denominator, 2 into 5. When bases are different and powers are same, so base will get multiply and power will remain same. 5 to the 10 to the power 6. Now see, after 6 digit it will get terminate. So after 6 digit means 5213 and 00 1 2 3 4 5 6. After 6 digit we will have to place decimal. Here 4 digit are there only, so we'll have to increase the number of 0 so that it will become 6 digit. So after 6 digit decimal will be placed. See here you will have to make the power same. It is 6, so make 5 to the power 6. For making it 6 we'll have to multiply with such number so that power get added to become 6. So we multiply 5 to the power in numerator and denominator. Student, take one more example. You can see here that 441/2 to the power 2 into 5 to the power 7 into 7 to the power 2. Question will be asked that check whether the given rational number is terminating or non-terminating. If terminating, after how many digit it will get terminate, and also write its decimal expansion, right? This will be the question, and this type of question asked so many times in board examination, so try to focus on this. First what you have to do, perform the prime factorization of 441. We get the prime factorization. Since denominator is already in the prime factors, product of prime factors form, so don't write its prime factors products. Now see, 7 is the common factor between numerator and denominator. Remove 7 from the numerator and denominator. 2 times 7 get removed. It will become 3 3 9/2 to the power 2 into 5 to the power 7. Now it is in form of p/2 to the power m into 5 to the power n. What is m? So 2 to the power m 5 to the power n, it is in form of p upon 2 to the power m 5 to the power n. It means that this whole number is terminating decimal expansion. Now the question is, after how many digit it get terminated? So which is greater, m is greater or n is greater? M is 2, n is 7, greater is 7. So after 7 digit it will get terminated. Now write its decimal expansion. How to write decimal expansion? Now pick this 9 upon 2 to the power 2 into 5 to the power 7. For making the power same, here highest power is 7, make the 2 as 7. For making it 7, you will have to multiply 2 to the power 5, because base is same, power will get added. 5 to 7, it will become 2 to the power 7, and 2 to the power 5 will become 32. 9 32 ja 288. Here denominators are different but power is same, multiply the denominators, it will become 5 to 10 to the power 7. So after 7 digit the decimal will terminate. So it will become 882 and 7. So it will 1 2 3, write 40, 1 2 3 40. So it will be 7 times 7 decimal places, decimal will terminate. Now this will become 0.0000288. So in this way we perform the questions, and this type of question are so many time in board examinations. So try to focus and study this topic very cautiously. Thank you so much.